Hello, everyone. Today's topic is elements and atoms. This is from ESA level chemistry syllabus and chemistry guide. This will be covering Cambridge, Edexcel, AQA, and Oxford syllabuses. This is one of the three videos which we are uploading about atomic structure. So, other two videos also you can go through. This video is covering elements and atoms. The next video will be inside the atom, and the third one will be numbers of nucleons. So these three videos will be covering the complete topic, which is atomic structure. So let us go through this video. So first of all, in atomic structure, elements and atoms, what we'll be discussing, we will be discussing what is an atom. So this is like the graphical concept if you get from about atom. So there is a central part also, and there are some things which are revolving around that central part. So if we define atom, it's is an atom is the smallest part of an element that can take part in chemical change. So everything that has mass is made up of atoms, and this includes everything, mean everything like solid, liquid, and gases, livings, non-livings, everything. So there are over 100 different kinds of atoms called chemical elements. So these are known as chemical elements. Next thing is, let us define the element also. If we define element is what? Element, there are different elements. We have seen the periodic chart also. And if we define elements contain only one type of atoms, that's specifically only one type of atoms. All matter is composed of atoms also. So next we need to know that how we are representing atoms. We are representing atoms in form of a periodic chart. Periodic chart we will be discussing separately, but this is like a modern periodic chart. We are showing in the form of elements in the form of symbols, and symbols are like this one. So it is having symbol is what? Symbol is a one or two letter abbreviation. So abbreviation is like for carbon we can take C, for oxygen we can take O, or Na is for sodium, and Fe for iron. So these are standard. We cannot take at our own. These are standard abbreviations which are specified. So for hydrogen it's H. We cannot take anything else. So these are the standards which we need to follow. Then next, what is atomic number? Atomic number is mentioned over here, and atomic number is basically number of protons in an atom. So we can say that it's inside the nucleus. Inside the nucleus are protons, which are the number of protons in the nucleus. Number of protons in the nucleus are represented by Z. So this number defines the element. So if number of protons in an atom changes, it element will change. So element will be identified by the number of protons inside the nucleus. Then mass number. Mass number is number of protons plus neutrons. This is name mentioned over here, which is hydrogen, and this is atomic mass. And atomic mass, as we discussed just now, that atomic mass is, or mass number is, number of protons plus number of neutrons. So we can say that A is mass number is equal to number of protons plus number of neutrons. This is how we are representing. Next, we can go through the fundamental particles of atom. What are the fundamental particles? If we go through the atom, this is like like for your understanding, we can go through this plan. It's like nucleus is inside, which is containing protons, positively charged, and neutrons, which are neutral particles, and electrons are revolving around the nucleus. So this is like the basic structure, fundamental particles which we have discussed. Atoms are made up of three types basically generally: protons, neutrons, and electrons. And then atomic number is represented by Z, which defines atomic number. Z defines an element, as we discussed earlier also, that for example hydrogen is hydrogen just because its nucleus is containing one proton. If a nucleus is containing two protons, it will not be hydrogen, it will be helium. Or similarly, number of protons will change, element will change. So by changing number of neutrons, element will not change. By changing electrons, element will not change. Element will be changing only when we change the number of protons inside the nucleus. Next is the mass number, which we discussed: number of protons plus neutrons, protons and neutrons, sum of that these two. Then isotopes. Isotopes are are same atoms, atoms of the same element, with different mass number of different number of neutrons. So everything, rest of everything is same, number of protons is same, but number of neutrons are different. And we can take examples of the isotopes also. What are the examples? Like very common example is of hydrogen, and we are representing it with 1h1, 1h2, and 1h3, which is protium, deuterium, tritium. Protium is having one proton inside the nucleus, no neutrons, and one electron revolving around the nucleus. And deuterium is having one proton, one neutron, and one electron revolving around the nucleus. Similarly, tritium is having one proton, two neutrons, and one electron. So in all three isotopes of hydrogen, there is one proton and one electron. The only difference is number of neutrons. Protium, 0 neutron; deuterium, one neutron; and tritium, two neutrons. So next we can go through carbon isotopes also, and carbon is having three isotopes: carbon 12, 13, 14. Carbon 12 we are taking standard also for relative atomic masses, you know. So carbon 12 is having 6 protons and 6 neutrons. Then carbon 13 is having 7 neutrons as indicated in this drawing, and 8 neutrons basically in this one also. This we have mentioned over here. Then we can have another isotope, which is chlorine. Chlorine is having two isotopes, which is chlorine 35 and 37. So this is basically mass number 35, 37. So proton number of protons is same in both cases. So 17 is number of protons. So this is basically, we have comprehensively done this. You can go through other two videos to complete the topic. As I told you, topic is atomic structure. So two videos are there. You can go to the playlist and check for that. Thank you very much for watching. Take care. Bye. Me.